This is section 9.2, arithmetic sequences. So an arithmetic sequence is a type of sequence where there is a common difference between each term. That just means that we are adding the same thing each time. So for this first sequence, 3, 6, 9, 12, we are adding 3 each time to get to the next term. Or we could say that the common difference is 3. 12 minus 9 is 3. 9 minus 6 is 3. 6 minus 3 is 3. So our common difference is 3. For the second sequence, we are, instead of adding 1, we're subtracting 1 each time. So our common difference is 2 minus 3 is negative 1. 3 minus 4 is negative 1. 4 minus 5 is negative 1. So our common difference is negative 1 for the sequence. The common difference is just what we are adding each time to get from one term to the next. So another way to think about an arithmetic sequence is just think the next term is where we are now plus that common difference. So if a sub 1 is a sub n then is the term before it plus our common difference. So to get to the next term, we take where we are now and add d, or our common difference. So we want to show, some of your homework problems will look like this. So we want to show that this sequence is arithmetic. And we also want to find the first term and the common difference. So to find the first term, we're just going to plug in 1 for n. So a sub 1 equals 3 times 1 minus 8, which is just 3 minus 8, which is negative 5. So our first term is negative 5. Now how are we going to find the common difference? Well, let's do this the way the homework is going to ask you to do it. So if we know that a sub n is 3n minus 8 and a sub n minus 1, so we're going to plug in n minus 1 for n. So this is the term before a sub n. So we have 3n minus 3 minus 8, which is 3n minus 11. Okay, so what do we do with this now? If a sub n is 3n minus 8, and a sub n minus 1 is 3n minus 11. To find our common difference, we can just subtract, because our common difference is the term minus the term before it. So minus 3n minus 11. So what do we have here? We have 3n minus 8 minus 3n plus 11, which is 3n minus 3n is 0. So we have negative 8 plus 11, which is 3. So our common difference is 3. And doing this, we've also shown that it is arithmetic, because we've shown that if you take any term and subtract the term before it, so a sub n minus a sub n minus 1, you will always get 3. So 3 is our common difference. Now if we look at our formula for a sub n, you notice that it looks like a linear equation where the slope is 3, because that's really what it is. Okay, your common difference is kind of like the slope in a linear equation. So let's do this one. We want to show that this sequence is arithmetic, find the first term and the common difference. So we're going to do this the same way we did before. Okay, so to find the first term, we have 9 over 16 minus 1 over 4, which is the same as 9 over 16 minus 4 over 16, which just gives us 5 over 16. So our first term is 5/16. Now to show that it's arithmetic and find the common difference, so we need to find a sub n minus 1, which is 9 over 16 minus n minus 1 over 4. And then we need to subtract a sub n minus a sub n minus 1. So we have 9 over 16 minus n over 4 minus a sub n minus 1, which is 9 over 16 minus n minus 1 over 4. So if we subtract, we distribute that negative through the parentheses. Okay, so we have 9/16 minus 9/16, so that part goes away. And we have negative n over 4 plus n minus 1 over 4. We have a common denominator already, so we have negative n plus n minus 1 all over 4, which gives us negative 1/4. So anytime we take one term from this sequence and subtract the term before it, we're going to get negative 1/4. So that is our common difference. Okay, so that's how we can show that an arithmetic sequence is arithmetic, and we can find the common difference. Now, what about a general formula for the nth term of an arithmetic sequence? So let's look at this here. We have a sub 1 is a, we'll just call it a, and then we add d, or a common difference each time, to get to the next term. So a sub 2 is a sub 1 plus d, and then a sub 3, we're going to take a sub 2 plus d, because that's how we go from one term to the next as we add d. So a sub 2 plus d, a sub 2 is just a sub 1 plus d. So we have a sub 1 plus d, which is just a sub 1 plus 2d. So how about a sub 4? Well, we take a sub 3, which is a sub 1 plus 2d, plus d. The term, we take a sub 3 plus d to get a sub 4. So now we have a sub 1 plus 3d. So how about a sub 5 now? We have a sub 4, which is a sub 1 plus 3d, plus d, which is just a sub 1 plus 4d. So do you see the pattern here? To find the nth term, a sub n, we're going to have a sub 1 plus n minus 1 times d. We had 4d for a sub 5, 3d for a sub 4. So for a sub n, we have a sub 1 plus n minus 1 times d. Because we're going to add d n minus 1 times to go from a sub 1 to a sub n. So using that formula, we can find a certain term of a sequence without having to actually go through and figure it out. So let's look at this sequence right here, 2, 6, 10, 14, 18. So the first term, a sub 1, is 2, and our common difference is 4, because we're adding 4 each time to get from one term to the next. So d is 4, and a sub 1 is 2. So we can just plug that into our formula. So a sub n, or a sub 31, because that's what we want, is a sub 1 plus n minus 1, so 31 minus 1, times d, which is 4. So we have 2 plus 32 times 4, which is, 30 times 4. I'm going to confuse you here. 31 minus 1 is 30. So we have 30 times 4. So we get 122. 2 plus 120, 122. So the 31st term of the sequence is 122. Okay, now what do we do here? For this particular question, it tells us what the 4th term is and the 20th term. And we want to find the first term, and we want to find a common difference, and we want to find a recursive formula for this. Well, what does that mean? So if we have the 4th term is 3, the 20th term is 35. So let's use the equation we just had up here before, which was a sub n equals a sub 1 plus n minus 1 times d. So that's the equation we're going to use. Now we know that the 4th term is 3. So a sub 4 is a sub 1 plus 4 minus 1 times d. And we know that the 4th term is 3. So that equals 3. Now we also know the 20th term. So a sub 20 equals a sub 1 plus 20 minus 1 times d. And we know that that equals 35 because that was given to us. A sub 4 is 3 and a sub 20 is 35. Well, let's simplify these two equations. So the first one is going to give us a sub 1 plus 3d equals 3. And the next equation will just be a sub 1 plus 19d equals 35. Well, look what we have here. We have a system of equations. We have two variables and two equations. So let's figure out what those two variables are. Why don't we just subtract the second equation minus the first equation? So a1 minus a1 is 0. 19d minus 3d is 16d. And 35 minus 3 is 32. So 16d is 32. Divide both sides by 16. And we get d equals 2. So there's one part. Our common difference now is 2. Well, we still need to find the first term, a sub 1. So let's use our first formula, a sub 1 plus 3d equals 3. Well, we know d is 2. So a sub 1 plus 3 times 2 equals 3. Subtract 6 from both sides because 3 times 2 is 6. And we get a sub 1 equals negative 3. Okay, now we know our common difference is 2, and our first term is negative 3. Well, what else does it ask us to find? It asks us to find a recursive formula for the arithmetic sequence. So that just means where we are now. So a sub n equals a sub n minus 1 plus 2. And there we go. That's a recursive formula for us. Okay, let's try that one more time with a different example. So here we have the 15th term is 0, and the 40th term is negative 50. So let's do the same thing. We're going to set up a system of equations. We're going to use the formula, so a sub n equals a sub 1 plus n minus 1 times d. So a sub 15, we know the 15th term is a sub 1 plus 15 minus 1, which is 14, times d. And we know that equals 0. That was given to us. And a sub 40, the 40th term, is a sub 1 plus 40 minus 1, which is 39, times d. And we know that is negative 50. Okay, well, we have a system of equations again. We have a sub 1 plus 14d equals 0, and a sub 1 plus 39d equals negative 50. So let's just subtract those two equations. A sub 1 minus a sub 1 is 0. 14d minus 39d would be negative 25d. And 0 minus a negative 50 would be 50. Divide both sides by negative 25, and we get d equals negative 2. Okay, so that's what we're adding each time is negative 2. So that's our common difference. Now to find a sub 1, we just need to plug it into our formula. So we have a sub 1 plus 14d equals 0, and we know d is negative 2. So we have a sub 1 minus 28 equals 0, add 28 to each side, and we get a sub 1 equals 28. So our first term is 28, and our common difference is negative 2. Okay, what about the sum of an arithmetic sequence? So if we want to know a sub 1 plus a sub 2, etc., all the way to a sub n, here's what we can do. So there's a couple of ways you can write this. N over 2 times a sub 1 plus n minus 1 times d, or just n over 2 times a sub 1 plus a sub n. And this is the second one is the formula that's most commonly used. This will be given to you on the final, so you don't need to memorize that formula. It is going to be given to you. So the sum of an arithmetic sequence, so s sub n, capital S for the sum, is n over 2 times the first term plus the last term. We're not going to prove this right now, but if you would like to, it is in your book, and we can talk about it in class on Monday, or you can just look over the proof. Okay, so let's find the sum of this particular sequence. We want to know the sum of the first n terms. So we don't know how many terms, so there still will be an n, but we're going to find the sum here. So we have n over 2 times n sub 1, or a sub 1, which is negative 1, plus a sub n, which is 4n minus 5. So we have n over 2 times 4n minus 6. So that would be the sum of the first n terms of this particular sequence. So we start at negative 1. You can see that we're adding 4 each time until we get to 4n minus 5. So n over 2 times 4n minus 6 would be the sum of the first n terms. Okay, now what about this one right here? Okay, this one we want to go from 2 plus 5 plus 8, etc., all the way to 41. So now we know when we need to stop, so we should be able to add this up. Now we could write all this out. We can see that our common difference is 3. So we could write out all the terms and add them up together if we wanted to. But let's use the formula instead. So we have n over 2 times our first term plus the last term. Well, the last term is 41. So we have n over 2 times 43. Okay, well, what's n? What term is 41? How many terms do we have to go to get there? So let's figure that out. How are we going to figure that out? Well, we know that a sub n will have to be equal to a sub 1 plus n minus 1 times d, because we're told that this is an arithmetic sequence. So we know that's our basic formula. Well, a sub n is 41. That's our nth term. equals a sub 1, which is 2, plus n minus 1 times d. Well, d, we already figured out, is 3. That's our common difference. So here we have an equation, 41 equals 2 plus n minus 1 times 3. Now we only have one variable. We should be able to solve for n. So we have 41 equals 2 plus 3n minus 3, which is 3n minus 1. So if we add 1 to each side, we should get 42 equals 3n. Divide both sides by 3, and we get n equals 14. Okay, so we just set up an equation to find what n is, because we knew what a sub n was, we knew what a sub 1 is, and we knew what d is, so we could find n. So that means 41 is the 14th term of this particular sequence. So we can plug in 14 for n right up here. So we have 14 over 2 times 43, which is 7 times 43, which is 301. So the sum of this sequence, 2 plus 5 plus 8 plus 11, etc., all the way to 41, would give us 301. Okay, so that's it for this section. Please feel free to rewind or rewatch examples as you're doing this. You can also watch the videos on my math lab for this section if that helps. Whatever you need to do to finish this homework. Please also email me with any questions. Also, this is the question I want you to email me. I want you to answer this email. This is from section 9.1. I want you to show why the sum from k equals 1 to n of k, so this sequence here, 1 plus 2 plus 3, etc., all the way up to n, will equal n times n plus 1 over 2. So this was the formula I gave you in class on Monday or Tuesday. Now I want you to figure this out. Why is this true? So go ahead and look through it, see if you can figure out why. Write out the first few terms and see if you can figure out why this formula is true. Now you can look this up if you would like to, but please think about it first, see if you can figure it out. And I want a thorough explanation. It doesn't have to be like a formal proof, but I want a very thorough explanation of why this formula is true. So please email me this before class on Monday. I need to get it before class starts, and it will count as a homework assignment. So please get this done by then and get your homework done this weekend, and have a happy Thanksgiving.